from a different position, so should you make it your X or?
I mean, it's up to you. Like, I think it's okay if you want to keep the X in the same place, because then it sort of shows you how you can get to that same point just by adjusting where it hits the mirror and where the light is coming from, right? You don't want to be moving too many things, right? Like, have you guys talked about constant variables, independent and dependent variables? Whatever you want. Like, it was cool. I liked the way the laser, the laser seemed really bright. It was hard to get the laser to stay on the piece of paper. Whatever you like. So 4 observations. It's exactly just whatever you think is interesting. What did you see when you did the lab? Okay? At the grade 10 level, we're practicing the idea of observing scientifically. So what did you see? There are no wrong answers, unless you said you saw a pink elephant wearing a tutu, and then maybe I might have to do something about that. Okay, just another couple minutes on this, and then I'm going to turn the lights on and talk about what we can do with our tracing. Yeah, all for $1.50 at the Dollar Tree. How strong is it?
More that way, like how she was doing it during that it hit me. Is that it?
It's hard to follow it, right? It's hard to find it. Like if you reflect it, can you get it to go across the classroom? If you move your X?
There.
Yeah. Okay. Interesting. So if you're done with this part, I'm going to ask you to carefully return your mirrors and have a seat. Okay? And sit in your group so that you have your drawing. Oh, is everybody done? Can I turn a light on now? Turn this light on. And yeah, I guess you need your lasers back up at the front and the mirrors back in the. Okay. Yeah, lasers right here. Perfect.
Is this graded?
Yep. We are getting a mark for this eventually.
Yeah, and then we went out.
Okay, so the mirrors go back over in the thing. Oh, you're going to need that again because we're going to want to measure that. Okay, but I'll take this and those things can go back over there. You need to keep, all of those, I just need the laser here. Okay, and the other parts go back over there, please. Thank you. Okay. All right. So those tracings, make sure you put the names of your groups on those. Okay.
I'll write our names on
Yeah.
the big piece of paper.
Because I'm going to collect those, and we can actually, I don't know if we have time today, we can do some measurements on them. But I want to make sure we have time for the second part, which is the refraction. Okay? So what you're doing now is making sure you've got your names on your tracings from this part of the lab, because I will collect them if we don't have time to do our calculations on them yet. Okay? But what did you notice? Did we notice anything interesting? Yes.
I noticed that tilt really certain angle to get it to hit the object paper.
Okay, so yeah, so you're saying it was a little bit difficult maybe to get the angle just right?
Yeah, because there's like one or two ways, there are many ways to do it, in my opinion.
There was a lot of different directions to consider.
It was hard to like pinpoint it at least somewhere.
Okay, so okay, good. All right, anybody, that's an excellent observation. Anybody have any other observations? Did it do what you expected it to do? Yeah? Okay. Did you observe anything that you didn't expect to see? Did anybody try anything other than reflecting it in the mirror? Like what? Good. Okay, so you tried to see if we could get it to go maybe across the room or something? Okay, all right, to see the strength of the laser. That's it, we're testing the strength. Okay, good. All right, so this is now refraction. Okay, and we talked about refraction a little bit yesterday. Where's my phone? Okay, and does anybody remember what refraction was? Want to remind me? Remind us what how refraction is different than reflection?
The light bounces off.
So it doesn't, instead of reflecting, it bounces kind of, like it changes path but not completely. Okay? Yep. Anything else we want to add to that? Okay. We were calculating something yesterday. Does anybody remember what that was?
Oh, sorry.
We're using the speed of light. And what of refraction were we calculating? Incidence of refraction, right? Okay. So in here, let's see here. Try and move this so that there we go. Okay. In here, I've got just regular tap water. Okay. In here, if you remember, the instructions said to make a solution of salt. Okay, that's what I have in here. What I'm going to try and do is add the salt to the bottom, the salt solution to the bottom, and sort of create a layer. I don't know, you guys might be able to see from up the front. I know you probably can't see from the back. Can you see it sort of, can you see the different things going in there? I might have to do this again. I didn't know that would be that cool for the people in the back to see. I'm going to leave it like, I don't know if, I'll try that much, and then if it doesn't work, we will try some more. That's the fun thing about science, right? Okay, now leave that off and leave those on. Turn this off just in case that it's going to affect this. So now it said to shine the laser in and, okay, see what happens. So if I shine the laser straight across, can you see it? Do you see the laser? I'm just shining it straight across. If you guys want to come up a little bit, probably that's a better idea. This is such a long, narrow classroom. It's bizarre. If you want to come up, come, Sebastian and Abdullah, come on up. So you guys can see, right? And sort of, I'll wait for everybody to come up so they can all have a good viewing point. Yeah, you're going to have to stand up. I can't see you, then you can't see the experiment, right? Okay. So the first thing I'm going to do is just, is shine it straight across. Do you see how I shine it straight across? And you can actually see the light go over to the little white box. See it? Okay. All right. Now, if I shine it on an angle, do we see? I don't know if it's dark enough. Do you see the light moving? Maybe if I put, so because what's supposed to happen is we're supposed to see the light kind of bending at the bottom. Oh yeah, you do kind of. Do you kind of see it? It's a little tricky. Devon, you might have to come around a little bit. Can you see that?
Is it like it's pointing there, but it's like reflecting a bit farther?
Yeah, it like from back. Let me see. If we might have to get right down to see it. Let's see here. Yeah, we need more. We need more salt because it's only bending right at the very end. So you guys get to see this then. Just watch what happens as I add the salt. Can you see it sort of looking like it's... Okay, I gotta add some more salt here because we need a thicker layer. Can you see the difference in the layer? It's a little tricky to see. The thing with this is that it has to be done, this part is sort of chemistry, because it has to be done just as we're ready to view it. Okay, so let's try it. Now I've got a slightly thicker layer there.
They do it from above the water?
What's that?
They do it in between, like above the water?
You can try it.
Yeah.
Do you see that? What does the light do now? It's reflecting off the bottom, which I'm noticing that. And see, I've got a light over there. You see it? Ah. Okay, but what we're supposed to be observing is the light changing direction in the actual solution.
It's like pointing there, but it's like pointing a bit forward here.
Yeah, it's kind of tricky to see. I don't know. Yeah. I mean, if I point it straight down, what do we see? Do you see anything? And then sort of angle it a little bit. Do we get to see anything? We're not really seeing too much. It's definitely not looking like what the diagram or the video told us. So that is definitely going to be an observation that we could include. Yeah. bright out today too. I can turn all the lights off and see if that helps. This would have been a good thing to do like last week when it was really dark. Okay, does that help at all? Yeah, can we get that blind closed? I don't know, can you reach it?
Dark side.
Yeah, I probably should have done, but if I move this now, it's all gonna mix up, but we can try it again tomorrow. That's a good plan. Tomorrow probably we should try this on the dark side of the class. Okay? Yeah, that's not gonna make a big difference.
I think that makes
Does it make any difference at all?
something.
And if I turn this like this to sort of try and block some more light? Yeah, okay. So, you can see it bouncing, right? So that's one thing, but we can't really see it. I wouldn't say we're observing refraction. Would you guys agree? It does curve on the bottom though, right?
Like goes with a different direction than the other place on top.
It is? You guys are seeing that?
Yeah.
That's awesome.
It's like one's like a bit ahead than the other.
Ah. So if you had to, okay. So maybe it just had to mix a little bit because it is kind of curving now. Okay, does everybody see that? Do you want to come in the front? If you need to come in the front to be able to see it, because I think you should. It's easy. It's more visible if you're looking at it straight on. Like how about if I do that? Does that help at all? Oh yeah.
What exactly are we looking for?
You're looking for the light to curve, like, so the idea, like when we were talking yesterday about light traveling at different speeds depending on the medium, do you remember? Like through air it travels at one speed and it travels at a straight line, but when it goes into water it travels a little bit slower, so it sort of bends, yeah.
When you talk about the ray, do you talk ray of light, ray of laser, like the laser ray?
Yes, the ray of light.
So is that what we talk about when we're describing what happened?
Yes. Okay. So the light comes in and then it changes direction because of the medium that it's traveling through. And that's refraction. Okay, so we're looking for the light to kind of go in and change a bit. I'll show the video. It draws what we're expecting to see. It is pretty tricky to see. I do actually think we're sort of, for some reason, it's starting to show more now than before. Because to me from here, it looks like it curves at the bottom and then goes back up again. Is that what you guys are seeing? Which I don't know if that's exactly what we're supposed to see, but curving straight light, right? Because we know that the laser is supposed to travel in a straight line. So getting it to curve is evidence of refraction, yes. Okay? All right, let's have a seat. I don't know if I would call that one a success or not. I like Keegan's idea of trying it in the dark part of the classroom. I think you'll try that tomorrow. I don't have time for enough salt solution to do that today. Okay. So, what I would like you guys to do now is add the normal to your tracings. What do you think that means? A straight line that's going to be what? Emily?
Up and down and perpendicular to the mirror.
Okay, perpendicular to the mirror. And where is that normal going to be on the mirror?
Would it depend on where the laser is?
It does depend on where the laser is.
Between, like directly down between the sides.
So at the point of intersection of the mirror. Does that make sense? Okay? Where your light hits the mirror is where you draw that normal at a perpendicular. Okay? So go ahead and try that. Yeah?
When we're drawing it here, how do we draw the mirror, or do we just put a straight line?
Straight line.
Do we just do like a box and it doesn't have to be? Can I borrow this? Supposed to be this? Yeah.
No, that's the refraction, right? Yeah, that's refraction. Now I'm talking about like here, this is good. Okay?
What exactly? How much is it?
And then
Actually, worth it. Actually, it's pretty much. I thought it would be $3. It's the little thing. What's that called? I always used to my sisters to be like, why should
I think, yeah, the wooden little cube.
yes, yes, okay. Because you end up with a bunch of different normals depending on where you're right? Excellent, this is good. And then you can, from that normal, you can measure your angles. Okay?
So actually, refraction is where the object is.
Oh, I didn't know this moved. That's cool. I had no idea.
Yeah. I wish I could hear you. It's all good.
So you guys can, I'm gonna collect these too. I'm gonna collect your labs. No, it's participation and observations. I'm looking at I'm looking for what you learned and what your understanding of this vocabulary and how it applies to the lab today.
You know how your drawing is like this, but ours, mine is like drawn like this? Should I just flip it then?
No, it's fine. Doesn't matter. I mean, a lot of people, more people actually draw it like that.
Like when I draw the angles, should I just do like from
Yeah, that's totally fine. I mean, you can draw, as long as it's labeled correctly, you can draw it whatever orientation you want, right?
And it doesn't have to like actually have the right angle of what we did here, right?
That's correct. It's just as long as it's labeled.
Okay.
Yep.
I don't think you need to put reflection, right? I think I just added all.
Yeah, as long as you have the angle of incidence and the angle of reflection. The rays don't have to be labeled, right?
Is this the vocabulary list for this question?
What?
And how many observations do we have to have?
That's whatever you want, really. I just need one.
For the laser, since we have the same
It's
object,
actually supposed to be
what if the angles be the same either way? As long as we're actually hitting the point, the angle will always be the same.
The incident and the refract, yes,
Oh, they can look.
yes. That's awesome. Okay, and then while you guys are finishing that up, one of these days I'll learn how to, oh, there we go.
I wrote.
Okay, so now we're gonna take a look at the last little bit of this video to help us understand some of our observations.
Based on the lines drawn in your paper, you should see clearly that light travels in straight lines. You should also notice that it bounces away from the mirror or reflects symmetrically. This is called the law of reflection, which says that the incident angle is equal to the reflected angle. These angles are measured from an imaginary line at 90 degrees to the surface or mirror, called the normal. In the second experiment, you investigated refraction. Pouring the salt water into the bottom of the tank, you created a density gradient. Lower down, the water was densest, and then it became gradually less dense as you approached the top. This caused light to bend or refract in interesting ways. When light bends from
Seriously? Oh. This time it's not my fault. Okay. So it's something about refraction today. We're not meant to understand refraction today. Because even the lab part is, even the video part of the refraction is not working.
Is the incident ray the one that we flashed?
Yes,
And then the reflection is
the one that comes back out again. Yep, that's perfect. What's up?
It would be the rays, like the laser.
Yeah. Okay. So I guess we'll have to watch this part tomorrow too, on the refraction. Okay, so. So I'm collecting two things from you today. I'm collecting your lab with your observations and your drawings. And then I'm also going to collect your tracings from the actual lab, okay?
Did they have to be?
What happened?
For the second drawing, I didn't see like
Yeah, so if you didn't see anything from the second drawing, you can leave that part blank because we didn't, the refraction one, I think we need to do it in a darker area if we're gonna be able to see it. It was sketchy at best, okay? Yes. Put everybody. But Keegan and Xenia have their own.
yeah, we're doing it together.
Yeah.
You know it, right?
Yeah.
Okay.
I don't think I do the mirrors.
But you can kind of see on this, it's sort of bending. But I don't think we're seeing that.
For the, I don't know if I do the laser properly, but like.
Do I submit these too?
Yep, and then I'll,
This is for me and Ahmed.
Okay.
This is my paper. I already stapled it.
you stapled it? Okay, cool, great.
Whatever this.
Yep, that's excellent. Yeah, there is a stapler if you want to staple them, okay? And then tomorrow we'll try the refraction one again, and we'll look at the homework questions that I assigned yesterday.